Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about orthographic projections of the solid. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have got the 3D projection of an object where the three views, that is the front view, then the top view and the left hand side view of the solid have been combined in a 3D isometric projection, and using these 3D isometric projections we are required to draw the front view, the top view and the left hand side views of this particular solid. So in order to draw the orthographic projections, we need to evaluate the sizes of the front view face, top view face and the side view face. Now if we are looking from this side, so this is going to be our front view. So from the front view, the width of the solid, it is equal to 44 millimeter, and the height of the solid, this is equal to 70 millimeter. So here we have, please check, this is 48 millimeter up to the center point, and then 22 millimeter is this radius of this top arc over here. So this semicircular surface is having the radius is equal to 22 millimeter. So 48 plus 22 gives us a height of 70 millimeter. So the front view face will be having the dimensions 44 millimeter, it is the width, and 70 millimeter is the height of the solid. Now in the top view, if we look at this solid, now we are going to get the width equal to 44 millimeter, and besides the width, the information required to draw the top view will be the depth of the solid. So this is the depth of the solid, which happens to be 60 millimeter. So the top view face will be having the dimensions 44 millimeter by 60 millimeter. And regarding the side view, in the side view we are going to require the depth of the solid, which happens to be 60 millimeter, and besides depth we also require information regarding the height. So height of the solid has already been evaluated in the front view, and this is equal to 70 millimeter. So the side view will be having the dimensions 60 millimeter by 70 millimeter. Now let us see different faces which we are going to observe while we are going to look at the solid from the front side, from the top side and from the left hand side over there. Now as we look at this solid from the front side, so these are the four surfaces which will be visible to us. Surface number 1, this is corresponding to the bottom web, right, which is having the dimension 44 millimeter by 10 millimeter. So this surface 1, it is parallel to the vertical plane. So the true shape of this surface or the rectangle, which is labeled as surface 1, will be obtained on the vertical plane. Then we have this inclined surface 2, which is a inclined rectangular surface. Now since this surface 2 is inclined to the vertical plane, so we are not going to observe the true shape of the surface 2 onto the vertical plane in the front view. So we are going to have a shorter projection corresponding to the surface number 2. Then the surface 3, please check. So around this particular circular portion we have got this circular web, and there is a base portion over there. So this entire surface is my surface 3, which is a flat portion. So since this is a flat portion, so this flat portion corresponding to the surface 3, which excludes this triangular web, and this excludes the circular projected portion over here, right? So whatever is the remainder portion of this surface, so this surface 3, it happens to be parallel to the vertical plane. So again the true shape of the surface will be viewed in the front view onto the vertical plane, and then you have this projected circular web over there, right? So this is a circular portion of the web, and here you have this circular web, it is parallel to the vertical plane. So on the vertical plane, that is corresponding to the circular web, so the true shape projections will be obtained on the vertical plane, right? So these are four surfaces which will be obtained while we are going to view the solid from the front side. Now let us view the solid from the side view. So if we are going to observe the solid or look at the solid from the left hand side, so first surface which will be observed is this one, surface number P. So please check, this is this surface number P, and corresponding to the horizontal web or the horizontal leg of this particular component which is having the surface P. So this horizontal web over here, this is parallel to the profile plane. So the true shape will be obtained of this horizontal surface onto the profile plane. But if I look at this vertical portion, into this vertical portion up to this portion, so this portion is parallel, but then this portion happens to be a circular portion. So since this is a circular portion, so the vertical leg, it will not be projected as 100% true shape onto the profile plane. So here apparent shape projections will be obtained onto the profile plane. So we can say that surface P, it will not be fully projected as true shape onto the profile plane, right? So this is my first surface P, because corresponding to this surface a simple rectangle will be obtained. So even though this surface happens to be a curved surface over there, so surface P partially up to this point, so this L portion will be projected as true shape, and beyond this L portion above this center point, so this portion will be projected over there as a apparent shape over there. And then this is my surface R. So again this surface R corresponds to circular projection. So since this is a circular projection, so while we look at the circular projection from the left hand side, only simple rectangle will be obtained onto the profile plane. So surface R will be again the apparent shape. It will not be the true shape of this particular circular cross section which will be obtained on the profile plane. Now when we look at the solid from the top, so these are the four surfaces which we are going to obtain: surface A, surface B, surface C, and surface D. Now surface A, it is a flat surface, so this flat surface will be excluding this triangular web, right? So this flat surface A, it is parallel to the horizontal plane, so the true shape of the flat surface A will be obtained on HP in the top view. Surface B is inclined, so this rectangular surface will be projected as a foreshortened or a reduced surface on the top view. Similarly, surface D is also curved and surface C is also curved. So D is also curved and C is also curved. So onto the horizontal plane, two rectangles will be obtained corresponding to surface D and corresponding to surface C. So we are going to obtain apparent shapes corresponding to these two surfaces onto the top view in the horizontal plane, right? So this was the brief description about different faces, how they will appear in the different views. Now in a single view, I am going to represent all these projections without dimension. Then we will see how we are going to go about construction of the front, top and left side views of this particular solid onto the scale. So let us draw these projections without scale. So if I have a solid located between horizontal plane, vertical plane and the profile plane in the first quadrant, so this object is lying above the horizontal plane and in front of the vertical plane. So object happens to lie in quadrant number 1. Now since the object is lying in quadrant 1, front view will be drawn above the XY line and top view will be drawn below the XY line. Now while I look at the solid from the front, so as I told you earlier that four faces they will be visible to me: surface 1, surface 2, surface 3 and surface 4. So the projections of surface 1, I told you they are the true shape projections. Surface 1. Surface 2, you can check, it is a big rectangle, but because it is inclined to the vertical plane, so on the vertical plane I am having the shorter projection, reduced projection of this large rectangular surface over there. So this is apparent shape projections which we have obtained in the front view. Then you have the third surface over here, which is this one, flatter surface. So since this flatter surface I told you it is beyond the circular portion that is on the outer periphery. So you can see it is this surface over there, and it excludes this web, and it excludes this projected circular web over here. So this surface number 3, it is this surface. Okay, so since this surface happens to be parallel to the vertical plane, so on the vertical plane I have been able to obtain the true shape of this surface on vertical plane. And then you have the surface number 4. So since this projected web, so it is a separate surface, so this surface happens to be again parallel to the vertical plane, so the true shape of this web has been obtained. So this circular web, it is projected as a true shape onto the vertical plane in the front view. Now let us look at this solid from the top. So as we are going to look at the solid from the top, so please check this portion. So this portion will be visible to me as a true shape. So this is my surface A. So please check this surface is my surface A. So this is true shape. But if I look at surface B, so this surface B, it is a reduced surface over here. So apparent shape is obtained. And as I told you earlier, this surface C and surface D, they are the curved surfaces, but from the top they will appear as rectangles over there. So again, surface C is this one, surface D is this one. So surface C and surface D, they are projected as apparent shapes in the top view. Now let's look at the surface from the side. So here my surface P is there. So up to this center point, please see, up to this center point, that is up to this point over here. So from where this arc is starting over there, so this portion of the surface P, this is true shape, but beyond this, that is the portion corresponding to the circular portion. So this is my apparent shape. So I cannot say that entire surface P is true shape. So we will say that surface P is represented as apparent shape onto the profile plane. So this is my profile plane. And similarly, surface Q, now this surface Q happens to be parallel. This is parallel to the profile plane. So here the true shape of surface Q will be obtained over here. And surface R, which is the projected circular web, so this is again a circular portion. From the side, it will be appearing as a rectangle over there. It is a projected rectangle as it appears from the side view. So again, this is an apparent shape. Okay, so this way, front view, top view and the side view projections can be obtained. So this was brief illustration without the dimensioning. Now let us start with the description involving the dimensioning of this particular solid. Now we are required to draw the front view, top view and left hand side view to dimension. So first thing, you draw the XY reference line, then draw the X1, Y1 reference line. So this is my transfer line, and since we are required to draw the left hand side view, so this left hand side view will be drawn on the right hand side of the front view. Front view will be drawn above the XY reference line, and the top view of the solid will be drawn below the XY reference line. Now let us draw the dimensions corresponding to the front face. So the front face, we know that it is having the dimensions 44 millimeter is the width and 70 millimeter is the height. So please check, we have marked 44 millimeter as the width of the front face and 70 millimeter we have marked as the height of this front face. So this is 44 millimeter width of the front face and 70 millimeter as the height. So we have obtained the rectangular face corresponding to the front view, and then the front view height projection has been carried forward onto the left hand side view, because in the left hand side view the height of the solid will be required, and similarly the width dimension, it has been projected onto the top view projection so that we can draw the top view. So in the top view we also require the depth of the solid, and the depth of the solid we know it is equal to 60 millimeter. Now we have drawn two projection lines separated by a distance of depth is equal to 60 millimeter. So the depth of the solid, it is equal to 60 millimeter, and this dimension of the depth will be transferred onto the left hand side view using this particular transfer line. So these horizontal lines, they will be projected onto the transfer line, and then they will be projected vertically into the left hand side view. So the left hand side view will be having dimensions: depth, it is equal to 60 millimeter, and the height of the left hand side view, it is equal to 70 millimeter. So 70 millimeter was drawn in the front view, and the 60 millimeter we have mentioned in the top view of this construction. So the front view surface has been obtained, top view surface has been obtained, and the left hand side view surface regarding the orthographic projections have been obtained. So this information has been appropriately used to obtain front view face, top view face, and the left hand side view face over there. So we are going to now omit this information, right, so that we can have a better view of this particular projection. Now let us start with the front view. So in the front view we have got the surface 1. So please check the surface 1. It is at a height of 10 millimeter. This is the height, 10 millimeter, and the width is 44 millimeter. So I have marked the height of 10 millimeter. Please check. Height of 10 millimeter has been marked. This is 10 millimeter, and the width, it is equal to 44 millimeter. So surface 1 has been obtained straight away by just constructing a single projection line over here. Now next we are required to draw this surface over there. This is equal to 15 millimeter. That is the top side of this triangular web. This will be at a distance of 15 millimeter from the top surface of surface A. From the top of surface A over here. So from the top of surface A, that is which is located 10 millimeter above the base. Now another 15 millimeter I am required to draw. So please check. This is another 15 millimeter which I have marked. So this will give me the location of top surface of this triangular web. And now I need to locate the axis of the circular portion. The axis of the circular portion, it is located 48 millimeters from the base. This is my bottom or the base. So 48 millimeters from the bottom, I have to draw this center line corresponding to these circular portions over there. So please check, I have marked 48 millimeter from the bottom. It is not from top of surface A or from this surface. It is from the bottom. So from the bottom, I have marked the horizontal line corresponding to the axis of these circular portions over there. Now I need to mark the vertical dimension as well so that the center can be located. So what is the location of this vertical axis line? This is center of 44. So center of 44 will be 22 millimeter either from the left side or 22 millimeter from the right side. So this is my center. So center has been marked. So once I have drawn the center, now I can mark the first circular portion over there. That is this hole. So this hole has been marked. So the radius is given to me as 10 millimeter. So the diameter will be 20 millimeter. So from this center, I have marked a radius of 10 millimeter or a diameter of 20 millimeter and drawn this hole over there. And since this hole is parallel to the vertical plane, so I can draw straight away the darkened hole over here. Now, what is the dimension of the outer portion of this particular web? So this is the inner hole, this is the outer web. So outer web is having the dimension is equal to radius as 15. That is the thickness of this web. It is equal to 5 millimeter. So this radius is 10, this radius is 15. So 15 minus 10 will give me 5 millimeter as the radius. So now my diameter of the outer circle will be 30 millimeter. But once I have drawn this particular circle regarding the inner hole, so automatically I have to project these projections first of all in the top view, and these projections I need to draw even in the left side view. Why? Because while I am drawing the top view, this hole will not be visible from the top. So I am going to get dotted line over here corresponding to this portion. right? So wherever this portion will be there, I have to draw a dotted line corresponding to this hole. Similarly, as you look at this particular solid from the left side, so once again, whatever portion will be there corresponding to this web thickness, so again I am going to get two dotted lines over here corresponding to these two projection lines over there. Now, having drawn this inner hole, now the outer boundary of this web needs to be drawn. So outer boundary will be having the diameter equal to 30 millimeter, or it will be having radius equal to 15 millimeter, so that this thickness of the web is equal to 5 millimeter. So this is the diameter, which is 30 millimeter. Now, after drawing this web, I need to complete this construction regarding this arc over here. So I know the radius of the arc. So from this center, the radius of the arc will be 22 millimeter. That is, this will become the diameter over here. So from this point, the radius I will be taking as 22 millimeter, and the web, this circular arc will be drawn. This is the circular arc which will be drawn. And another thing, having drawn this outer portion of this circular web, so again I have drawn projections towards the left hand side view, and I have also drawn projections towards the top view. Why? Because the outer boundary will be visible to me even in the top view and even in the side view. In the top view, this diameter will be visible, and in the side view, this diameter will be visible. Now we have marked all the dimensions in the front view. Now let us complete the front view of this particular solid. Now the radius 22 millimeter has been marked over here. Now we are going to join, please check, the vertical edges of the surface 3. So the vertical edges of the surface 3, they have been joined up to the bottom. So this is going up to the bottom because this is also going up to the bottom. And then we are going to mark this thickness of 10 millimeter corresponding to the surface A, right? Surface 1 over here. And this web I have not marked yet. So this one web, it is still missing. So this I will be able to mark because I am having this center point. So I have the center point. I know the width of this web, which is equal to 10 millimeter. So width of this web is equal to 10 millimeter, means that it will be having an offset of 5 millimeter on either side. So I am, please check, offset on right and 5 millimeter offset on the left side. So height 15 millimeter I have already marked. Please check, this height of 15 millimeter was already marked. So this rectangle right over here, this gives me the front view projection corresponding to the surface number 2. So surface number 1, it is this rectangle, true shape. Surface number 2, it is this rectangle, it is apparent shape. Surface number 3, again parallel to the vertical plane. So on the vertical plane in the front view, true shape has been obtained corresponding to this surface number 3. And then surface number 4, this is the projected web. This is the projected circular web having a thickness of 5 millimeter. So this is the web, circular one, having the thickness equal to 5. So again, surface 4 is true shape, surface 3 is true shape, surface 1 is true shape, and surface number 2, it is apparent shape. So 1, 3 and 4 surfaces, they happen to be true shape. Surface 2 happens to be apparent shape. Now front view has been completed. Now we are going to move on to the top view. So in the top view, please check, we have got this thickness of this web equal to 15 millimeter. So this thickness, or you can call it a depth over there. So from this corner, so 15 millimeter depth we have drawn. So this is my 15 millimeter depth which is lying on the back side. So this is the rear end of the solid. This is front end of the solid. So on the rear end, depth of the web, it is equal to 15 millimeter, and it has been marked in the top view, and this has also been marked in the side view. because the same dimension we are going to require regarding this depth in the side view while we are going to look at the solid from the left hand side. So this depth has been marked. Now next we have got this depth of this particular circular web. It is equal to 10 millimeter. So again 10 millimeter, it is corresponding to this circular web. This has also been marked over there, 10 millimeter. Okay, so this is 10 millimeter corresponding to the circular web, 15 millimeter corresponding to the surface P over here. So this is 15, this is equal to 10. So both these, you see, projection they have been obtained over here. And then next one, this is, I have got, this is 15 millimeter, so this is total 25. So this total 25 has been drawn for obtaining this triangular web over there. So once I obtain the triangular web, I will be able to obtain it over here. And then let us now complete the top view. So top view, this outer boundary will be visible. Yes, it is visible. Outer boundary over here, this is visible to me. Then this particular first web, which is corresponding to the surface P. So this is a circular portion, but it is observed as a rectangle in the top view having width equal to 44 millimeter. So I'll draw a line over there, darkened one. So this is my surface number D. So this is my apparent shape of the surface number D over here. Next, I have got a surface number C. So surface C, please check, it will be lying between this diameter. What is this diameter? It is equal to 30 millimeter. So where does it appear in the top view? You bring projections over here. So this width, it is equal to 30 millimeter. Starting from here, it is ending up here. And what is the depth over here? Depth is equal to 10 millimeter. So this depth of this circular projected web, it is equal to 10 millimeter. So let me darken this. This is again rectangle. So this is top view of surface C, again apparent shape. This is surface D, apparent shape. And now I need to draw this portion. So this portion will be, please check this total depth. It is equal to 25 millimeter. But this 25 millimeter is starting from the surface D. But I have already drawn this depth of 10 millimeter corresponding to surface C. So beyond surface C, my remaining depth will be 15. So please check, this was 15 corresponding to surface D. Then I have got 10 millimeter corresponding to surface C. This is 10 millimeter corresponding to surface C. Then remaining 15 millimeter, it is there, remaining 15 millimeter. So this portion is visible, but this portion will be dotted. So this portion of 10 millimeter, it will be coming under the surface C. So surface C 10 millimeter length, it is going to overlap or overshadow this portion, this trapezoid portion of this triangular wedge over here, right? So this portion will be drawn dotted over here, right? So total depth over here will be 25 starting from this point. So this is my top view. So in the top view, please check, this is the dotted portion which I have drawn corresponding to the circular hole. So this is a circular hole having diameter is equal to 20. So please check, this is my internal circle or the hole. So this is having diameter 20 or radius 10. And while I bring it down, so this total portion will be dotted, right? So this portion will be dotted. And 4 surfaces I have been able to obtain. Surface A, true shape. Surface B, apparent shape. Surface C, apparent shape. And surface D, again apparent shape. Now let us draw the left hand side view. So as you observe the solid from the left side, so all the projections, all the dimensions, they have been marked. Only thing is we have to do the darkening. So the base is visible, yes. This edge is visible, rear edge, yes. Then this portion will appear to me as a rectangular portion. This portion will appear to me as a rectangular portion, that is vertical portion of this face P. Okay, so this is my rectangular portion. So this was a semicircular arc, but from the left hand side it appears as a rectangle. So this is an apparent shape. Now from the bottom 10 millimeter, it is the height of the surface A, 10 millimeter, and then I'll draw 10 millimeter over here. So this completes my surface P projection over here. Now surface Q, I know the height. How much? 15 millimeter. I know the width or the depth, 25. So it starts from this point, it ends over here. So starting from here means it will start from this point, it will end up over here. Starting here, it will be ending up over here. So this is true shape of the surface Q. True shape of the surface Q has been obtained. Now next I have to draw projections regarding this circular web over here. And what is the depth? 10 millimeter. I know this depth, it is equal to 10 millimeter. What is the diameter which I will be able to see from the side view? This diameter. So this will be the diameter which is equal to 30 millimeter, and this will be my depth 10. So the diameter 30, it appears over here. I am going to project this. So this is going to be my H. Again, this is going to be my H. So this is 10 millimeter, and this height over here, this will be 30 millimeter. So this way the circular portion of this projected web, it again appears as a rectangle. So what is this shape? Apparent shape over there. So surface C, it is apparent shape, that is surface R. So this is my surface R from the side view. This is also the apparent shape. But one thing is missing in this view. What is that? This hole. So there is a hole over here having diameter is equal to 20 millimeter. So where is this hole? I have this hole over here, 20 millimeter. Now I will be projecting it. So this portion will be dotted. Similarly, I will be projecting it over here. So this portion of this web will be dotted. So this is dotted and this is also dotted. Now this is the complete construction of the left hand side view, right? So let us put down the faces. Surface P, apparent shape on the profile plane, because here you had the curved surface over here. Surface Q, it is true shape because this is parallel to the profile plane. Surface R, it is a circular surface and it appears as a rectangle on the profile plane. Again an apparent shape. So all the faces in the front view, in the top view, as well as in the side view, they have been obtained, right? So this way we have been able to construct the orthographic projections from the isometric 3D projection of the object over there. And now we can remove these surfaces so that we can have a better understanding of the orthographic projections. We can have a better correlation between these orthographic projections and these isometric projections over there. So we can see that all these surfaces which were marked appropriately in the isometric projections, they have been drawn and they have been developed in the orthographic projection. So this is all for today. So we'll be continuing with few more applications of the construction of orthographic projections when the isometric construction or the 3D construction of the solid is available with us. So thank you very much. Thanks a lot.